One-sided infinite limits and vertical asymptotes. While these two things are kind of related, and we'll try to understand them with the help of this example. The question here is, determine limit of 2 divided by x minus 5 as x approaches 5 from left side. That minus indicates left side. And limit x approaches 5 from right side for 2 divided by x minus 5. So we have a function here which is 2 divided by x minus 5, and we need to find its limit as x approaches 5 from left side and from right side. That is what we need to figure out. So let me just first give you a rough sketch here for the given function, which is 2 divided by x minus 5. As you know, if I put x equals to 5, then there'll be 2 over 0, which is undefined. So at 5 it is undefined. So we have a vertical asymptote at 5. X equals to 5, we have a vertical asymptote. So it's a reciprocal function which is shifted 5 units to the right, and vertically stretched by a factor of 2. Now that reciprocal function which is shifted with vertical asymptote now at 5 will look something like this. So I'm not putting the values here since we are interested in the region close to 5, right? So that is how our function is going to look like. Now the question here is, determine the limit of this function, and the function is f of x equals to 2 over x minus 5. So when we are trying to find the limit, we can actually substitute some values and check for ourselves what value are we approaching. So 5, so let's do this part first, where just limit x approaches 5 from left side. This means we are approaching from left side, and the function is 2 over x minus 5. So we can take a value which is very close to 5 but slightly less than that, right? So let's try a value which is like 2 over, let me write x is 4.999, right? So we are approaching 5 from left side, right? That means less than 5. We'll use calculator and figure this out. So it is 2 divided by, within brackets, 4.999, take away 5, bracket close, equals to minus 2000. So what we get here is minus 2000. Now minus 2000 is a very large value as compared to these small numbers, right? 2, 5 and 4, correct? So it's extremely large value. So what we really see is that the function increases unbound as we are approaching 5 from the left side, right? So we can also write this as minus infinity. Remember one thing, that infinity is not a number. So strictly speaking, we say limit does not exist. Remember that part. Limit does not exist. We write minus infinity to indicate it's increasing unbound. Towards negative side, d bound, right? So that is what we're trying to say here. Now let us also check the limit of the function as x approaches 5, but this time it is from the right side. Do you understand that this plus indicates from the right side, and the function is 2 over x minus 5. So what we will do now here is, when we are approaching from the right side, that means this side, and that value is 5 for us, correct? So the value has to be very, very close to 5. So this time what we will do is, we'll place x as equals to 5.001, which is very close to 5. So we can write this as 5.001 minus 5. And let's figure it out. How much is this? So we have 2 divided by, within brackets, 5.001 minus 5, bracket close, equals to 2000. So this time we get a positive value, right? As you can see, it is indeed a positive value, and 2000 is extremely high, correct? So we can write this as positive infinity. So infinity indicates that the function is increasing unbound, right? So without any boundaries. So that is what it is saying. But there is no particular value which the function is approaching, right? So we again say the limit does not exist. So we sometimes will be using does not exist, right? So does not exist will mean that the limit is either going to positive infinity side or negative infinity side. But it's kind of good to write positive and negative infinity so that you get an idea that your graph is approaching unbound but on the positive side. Negative infinity unbound towards the negative side. That's the whole idea. And of course, as you can see, we are not approaching a particular value, so limit does not exist for both of them. So that is our answer for the given question. With this, you should also understand that this point x equals to 5 actually represents a vertical asymptote. So in this particular example, we notice that as the x value approaches 5, the function approaches positive or negative infinity. Well, that implies that the line x equals to 5 is a vertical asymptote, right? So vertical asymptote is a line which the function is approaching as we are approaching the value 5. So that is how one-side limits and the vertical asymptotes are kind of related, right? We'll explore more of this in the next video. Thank you and all the best.